The Boolean modifier allows us to create complex objects very quickly by combining the geometry of two models or more together in a variety of ways. To access the Boolean modifier for your object, first of all, ensure the object is selected. Then go to the Modifiers tab in the Properties panel. From here, select Add Modifier, Generate, and then choose Boolean from the list. The first parameter we're going to look at is the object parameter. If you take a look at the icon for the Boolean modifier, you will see that it's currently red. This indicates that the modifier has no impact on our model at this time. We need at least one object to act as the Boolean. To do this, I'm going to create a second object in my 3D viewport. For now, it's just going to be a second cube, and I'm going to rename it as Boolean just so we can best identify it. Then I'm going to hit the G key and lock to the Y-axis to move across, and then hit the S key to scale down. I'll just make sure that the two objects are overlapping in terms of their geometry, and then I'm going to return to the cube object. Now I'm going to go to the object parameter, and I can either left click to bring up a menu and choose my target object from here, or I can use this icon which is like an eyedropper, and I can select the object that I want to act as the Boolean. So I'm going to left click, and now the Boolean modifier is in effect. Regardless of the method used for your Boolean, one of the key issues of using this modifier is in fact the display of the Boolean target itself. Currently, it's preventing us from seeing the effect of the Boolean modifier. To fix this, we're going to change the display of the Boolean object. To do this, select the object, then go to the Object tab in the Properties panel. Come down to where it says Viewport Display and open up this section. Scroll down to where it says Display As. It may read as textured. Left click and choose Wire from this menu. The Boolean object now appears as a wireframe, which means we can see its impact on the main object using the Boolean modifier. You might get asked the question, why don't we just hide the Boolean object? But the problem with hiding an object is you can't manipulate its position. So if I was to hide the Boolean object, even if I left click to select it in my outliner panel, and then go and access the move tool, I cannot actually manipulate any hidden objects. This is why it's better to actually change the display of your Boolean object so that you can still see and manipulate the object whilst also viewing its impact on your object. If we return to the main cube and also the Modifiers tab, we can now focus our attention on the top three parameters. Currently it is set to difference, but we could also choose union and intersect, and these are the three main types of Boolean in Blender. Now before we move on to union or intersect, you can see the current impact that the difference parameter is having on our model. It's taking our Boolean object, and whatever geometry overlaps, that is being used to create new geometry within the model. If I was to hit the G key to manipulate the positioning of this Boolean target, it will change the impact on our main object in real time. To best preview the Boolean modifier's effect, we're going to quickly apply it by clicking on this drop down arrow and selecting apply. Now we can successfully hide the Boolean object, and begin to manipulate our main model, and the geometry will no longer change because it has now been confirmed after applying the Boolean modifier. So at this point, this was the result that we ended up with. Of the 3 Boolean methods, difference is probably the easiest one to work with. But for now, let's just go back in time using Ctrl-Z to undo, and then let's change to another method. For example, let's go with union. Union effectively combines the geometry of both the main object as well as the target object. Now keep in mind that if we take a look on the inside, it should be able to do what you see here. It should be able to cut on the inside, whereas the difference cuts on the outside. This may not always be the case, but that may be due to the solver that you select, which we will cover in a few moments. Again, for now, I'm going to manipulate the positioning of the Boolean object. So I'm going to hit G and then Z to bring that down. Let's just have a look on the inside, just to confirm the effect that it's having on the inside of our model. And then I'm going to select the main object and apply the Boolean modifier using the union method. Let's hide the Boolean object until we're left with the default cube and the impact that the modifier had on the cube itself. The final option is for the intersect Boolean method. Again, I'm going to use Ctrl-C a few times to bring back the Boolean modifier, and this time I'm going to change from union to intersect. Now what this is going to do is it's going to maintain the geometry that exists where the 2 objects intersect. So think of it this way. If we go with difference, we are using the Boolean target to cut into the main object. If we are going to go with the union option, we are adding the geometry of the Boolean to the object shell. So in terms of the geometry of the Boolean target, it's actually that which intersects on the inside that is going to be removed when we apply the modifier. So difference cuts into the object and the union creates geometry on the outside. Intersect will find the geometry of the Boolean target that overlaps with the main model, and it will maintain that geometry when the Boolean is applied. So if we go and apply the Boolean modifier now and hide the Boolean object, we are literally left with a resized cube. Let's create a slightly different example. So I'm going to press undo a few times, and I'm actually going to hide the Boolean object. I'm also going to remove the Boolean objects here in the modifier. Next, I'm going to bring in a cylinder object, and I'm going to rotate it on the x-axis by 90 degrees, scale it down, then scale it on the y-axis. So here we have a cylinder cutting through the main object. We're going to name this cylinder as pipe. So we've got a pipe going through a block. Now I'm going to define the pipe as my new Boolean object. Again, you're going to see some overlapping here of the geometry when set to union, which it currently is. So we're going to, with the pipe selected, change its viewport display to wire. We can also, if we want, reset it to bounds, and that should have a sort of similar effect, but it looks more like a cube because the bounds refer to the max height, width and depth of the object. So here I'm just going to set to wire, and now we can see what effect it will have if we were to use the union method. If we switch to difference, we're using the pipe to cut a hole in the block rather than having the pipe pass through it. And if we set to intersect, then we're effectively using the main object to create a smaller version of the cylinder. Now the Boolean actually works with objects that have multiple islands. An island is effectively a unique part of the geometry or a specific part of the mesh that is detached from another part. So with regards to our pipe object here, what I'm going to do is just move to the difference option for the moment. I'm going to take this object and I'm going to just scale it down, and we're going to scale it down, I think, on the Y plane to something like this, and just reposition. I'm then going to duplicate it with Shift D and bring the duplicated version of the object down here, but I'm currently doing this in object mode, so when I do this it becomes a different object, and you should just about see that we're no longer affecting the model. So instead what I want to do is I want to go into edit mode and then duplicate the mesh. When I do that, I can reposition the new geometry, and if we refocus our attention on our cube object, you can see we now have two holes. So even though we have two different sections of our pipe object, both of these sections are impacting the main model because they're both part of the same object. Another way to use the Boolean modifier is to change the operand type from object to collection. For this to work, we need at least one object in another collection. I'm going to detach the pipe object here, and I'm going to change the operand type to collection, but currently we only have access to the collection that the cube is a part of, and this isn't really going to work properly because it needs to locate objects in another collection, as well as if we just bring this out, noting that the selected collection contains non-mesh elements. Now if you take a look at this collection, you will see that we have a light object and a camera object. Now these are not mesh objects, and this is why the Boolean modifier is bringing up this error message. What we're going to do instead is we're going to hide the pipe object, and we're going to add a new collection. So I'm going to come over to the outliner panel, right click and select new collection. We're going to name this as Boolean collection, and here I'm going to add a few objects. The first object I'm going to add here is a cube, and we're just going to reposition to around about here. With each object that I add, I'm going to change its display to wire. The next object I'm going to add is going to be a cylinder, and I'm going to move the cylinder over here, scale it down a bit, reposition, and scale up on the Z-axis. Again, let's change the display to wire. And the final object that I want to add, and you'll notice that we're adding these to the Boolean collection because this was the selected one. The final object that I want to add is going to be, let's go with a monkey object. And I'm going to reposition the monkey object to around about here. Like so. So we have 3 different objects all within the same collection. We're going to return to our main cube object, go to the Modifiers tab, and we're going to change our collection from Boolean 1 to Boolean collection. Probably should have renamed this as Boolean 2, but we're just going to left click. I've also, by the way, named it completely wrong, so I am actually going to rename as Boolean2. And as soon as I do that, you should see that all three of these models are affecting the main cube object. And I can manipulate any of these objects in any way that I require to get a new shape for the main model. You may have just noticed that when we select one of these objects and move the object around our viewport, that the transition begins to lag. So you can see it's just a little bit laggy there as I move this cube around. And that's just the cube. We also have our Suzanne object as well as the cylinder, and they all do the same thing. They all appear to be struggling for movement or control in the 3D viewport. This is because of the solver method we are using. So by default, you will be using the exact method. This will give you the best possible results when you apply your Boolean. The fast method is much better for when you are editing the model, and in most cases will give you the same result as the exact method. But when working with a lot more geometry, both in terms of your main object as well as your Boolean objects, you may see some differences between the solver's result and the exact result. In general, you should ideally, while using the Boolean modifier, use the fast solver to maximize performance, especially if you're using a collection like we are here. And then you'd want to use the exact method when you were to apply the Boolean modifier. Here we have an example of Suzanne along with a sphere. Now both of these have been subdivided so that they have a lot more geometry to work with. So if I go into edit mode for Suzanne, you can't even see all of the individual faces until we zoom right in. And the same is going to be the case in this example for our UV sphere. So I'll select the sphere, go into edit mode, and you can see just how long it takes for my machine to load it up. And there you can see just how many vertices and faces we have for the sphere. Now what we're also doing here in this example is we're using the Boolean modifier and setting the object to the sphere. Now if I was to take my sphere and hit the G key, watch what happens to the performance of my 3D viewport. I'm pressing G, I'm moving, and it's actually taking a while for the 3D viewport to respond. Eventually it does. But you can see just how much of an effect the Boolean modifier can have on the performance of your viewport. I'm just going to hit the right mouse button to undo this example. So I'm basically going to cancel the operation and reselect Suzanne. Now I have so much geometry here that even the fast solver is going to struggle, but it should perform better. However, I want you to take a close look at the intersection between our UV sphere and Suzanne. It looks pretty good at the moment. If I change to fast, you will begin to see some artifacts appear in this example. So this is where the Boolean isn't quite able to line up the geometry correctly. And if we were to apply the Boolean modifier, we would get these artifacts, which is a result of potential overlapping of geometry. That being said, if I was to select our sphere and press the G key to begin moving, the performance is improved, and you can see it's improved compared to the exact solver. It's not perfect, but we're able to move our UV sphere more easily. So that's effectively the difference between the exact solver, which allows for the best possible results, and the fast solver, which allows for better performance in the viewport while working. When choosing the fast solver method, you have the following solver option, which is the overlap threshold. Now this is set to a very, very small value. And what this does effectively is it determines the distance between potentially overlapping geometry and attempts to correctly reposition the geometry created using the Boolean. What this means is that the higher you make this value, the more precise the fast solver will be. However, at the same time, this also means that you can end up reducing the overall performance of the fast solver, and if you're not careful, this is an easy way of crashing Blender if you are using objects with a substantial amount of geometry. When using the exact solver method, we have the ability to control how new materials are going to be added where the booleans are created. So before we had a look at fast solvers and the overlap threshold, because by default the fast solver does not deal with overlapping geometry very well, and you need to increase this value for it to function with a more exact calculation. Of course, we've already discussed the negatives of doing so, but with the exact method we don't have anything like that. Instead, the solver options relate to materials. Now for our example, I've gone ahead and added some materials to a couple of our objects. The main cube, for example, has 3 materials: blue, red and green. Now if I go into material preview, it's currently assigned the blue material, and I can still select any of these materials that I want to assign them to my objects. For example, if I go into face select, I can just take this bottom face and we can make that a green color. However, what about the effect of the Boolean? How will this affect the material of the model? Well, currently we're using an index-based option for our materials. This basically means in this example that we will be using the material found in the first slot, which also happens to be applied to the object anyway. But what if I was to change the order of these materials? Let's take the red material, for example, and bring it up to the top. When I do so, anywhere where we have cut into the object using the Boolean becomes red. This is because the Boolean modifier is using an index-based calculation to determine which materials are going to be assigned to the model where the Boolean creates the new geometry. This means that it's going to look for the first available material in this list, which is currently the red material. If we take the green material and bring it to the top, that geometry becomes green. If we select the blue and bring it to the top, it becomes blue. For now, let's just pop it back to red. And I've also added a material to my Suzanne object, so it currently has a yellow material. Now, what if I wanted to transfer this material over to the main object as I cut into the Boolean? Well, to do that, I would go back to my object's Boolean modifier and I would change the material method from index-based to transfer. When I do this, the Suzanne object in particular and the geometry that it creates will be assigned the yellow material color. Also note that when I make this change here, it doesn't actually change what we see with the other Boolean objects. So the cube and the cylinder still present that red color, which is equivalent to using the index-based material type. So you would use index-based so that all of the Booleans will use the top slot primarily, or you could use the transfer option, which will take the materials of the Boolean objects and apply them to the cuts on the main model. Another reason why you would want to choose one solver over the other is when you have a Boolean that's face overlaps the face of the main model. In this example, I've got the main model as a cube and a secondary object acting as the Boolean, which is this cylinder. Now, both of these objects are the same height. That means that you have the Boolean object's main face at the very top overlapping with the top face of the cube. Now, you might think to yourself, well, that shouldn't be a problem, because after all, the whole point of the Boolean is to just cut into the mesh. However, if we take a look at the solvers, we're currently using the exact solver. Keep an eye on this area of the geometry as I switch to the fast solver. When I do that, we get a problem. Blender doesn't seem to be able to correctly create the Boolean, and so the geometry is actually maintained on the main model. If you zoom in, you can see even this area of the model, not just the top face, is maintained. So in order for this to work, we would either have to scale the cylinder down, and now the actual fast solver begins to work, or if we didn't want to do that, we would have to use the exact solver, and that would allow us to better calculate the Boolean compared to the main model, even if faces are overlapping in this manner. Now, underneath the exact solver options, you'll have one or two options. One if you are using a collection, and two if you are using a single object. So the one option that you always have is the hole tolerant checkbox. All this does is it improves the exact solver's calculation when holes are created as a result of the Boolean. So for example, I can take our cylinder here and just grab it and move it across to here to create a hole that basically goes all the way through the mesh. The idea for this checkbox is to just improve the calculation of creating the hole so that the result is cleaner. Now, in this scenario, we're using a low poly cylinder with a low poly cube, so there isn't going to be any real difference here. But if you're using a much more complicated mesh, especially one as your main model, then you may want to check this hole tolerant option if you see that there are any visual artifacts despite using the exact solver. The other option is self-intersection. Now, I may have jumped ahead a little bit, so I'm going to just go back to what we were before. So before we were on collection for the Operand type, and we only had a single option. If you turn that to an object and create your object for the Boolean, you'll have access to self-intersection. And this just allows self-intersection of the Boolean geometry within your Operand. All you need to know about this option, like hole tolerant, is that it just improves the final result in specific areas of the model, just in case you see anything like artifacts where the geometry is being created as a result of the Boolean. So you'll want these two to be checked for those more complex models, but for something like this, the actual result is exactly the same because there's not an awful lot of information that Blender has to work through. Again, these are entirely optional, and you only really need to tick these boxes if there are notable artifacts in your model at certain locations when using the exact solver. You can improve the ease of use with the Boolean modifier by adding an extension known as the Bool tool extension. Go to Edit, Preferences, and then go to Get Extensions. If you are using a version of Blender that is older than version 4.3, this may not exist, and you may need to go into your add-ons in order to locate it. Under Getting Extensions though, simply type into the search bar at the top, Bool, and you should have two options, the Bool tool and Booltron. It should look like this, so if I just uninstall quickly, you have two options here. You'll want to select the Bool tool and click install. This should only take a few seconds, but once it's installed, you should be ready to use it. Close the Preferences panel, and then you should select the Boolean object first and the main object second. If we use the Control key and then press the plus key on our number pad, it's going to add a unique Boolean called Boolean Sphere, because we've chosen the sphere as our Boolean object, and it's set it to the union parameter, so it's the union type of the Boolean modifier. If I use Control and Z to undo that, and then use Control and then the minus key on my number pad, it's going to use the difference parameter. If I use Control and Z again, and then use Control and the asterisk, which is used for multiplication, it will use the intersect method instead of union or difference. So this is effectively a way of adding these three types of Boolean to a keyboard shortcut system that you can use to more quickly identify and create Boolean models within your scenes. This time we have multiple smaller spheres, and again I'm going to use the Bool tool. But this time, if I use the Bool tool in this scenario with 5 different spheres acting as my Booleans, I can use Control and the minus key, for example, on my number pad, and it's going to create a Boolean modifier for each individual one. So it's not going to create a single Boolean modifier as a collection, but rather it's going to use the operand type of object for each individual version of our spheres. Now the advantage of this is perhaps that we can manipulate individual spheres if we need to. The Bool tool is very comprehensive. You also have access to many of its options, such as in the side panel where you can choose an auto Boolean or a brush Boolean option. Or you can even come over to the box carve tool. Now this isn't a tutorial on the Bool tool itself, we're just highlighting the Bool tool's capabilities to make the Boolean modifier easier to use. So the last thing I'm going to demonstrate to you here is the ability to, rather than just adding the modifier, also applying it immediately. So to do that, we're going to use the Control key, Shift key, and if we want to use the difference operation, we're going to press minus on our number pad. As soon as I do that, you'll see that the Boolean tool has taken effect on our model, but it has also removed the objects that were used for the Boolean. So we have no modifier currently active. What effectively happened was we added the modifier using the difference type, and then we immediately applied it, and then we deleted the objects that were used for the Boolean. So that's a very, very quick way of applying the Boolean modifier to your mesh. But that wraps up pretty much everything that you need to know about the Boolean modifier. I hope it was useful to you, and keep an eye out for more videos on different tools and modifiers in Blender. We're trying to get through as many of the different tools as we can, and we want to go into as much detail as possible so that you know exactly how to use each tool and modifier that you may come across. That's it for now though, so thanks again guys, and take care.